Hello everyone. So today we are solving another question of JDOS 2015. This is on the topic of ray optics. This was a paragraph type of question, so this was quite lengthy to read, but I'm sure like it won't be that much long to solve here. So let's read our question. So they're given slide guidance. So basically, they have described the optical fiber that I'll describe you in the short. I'll here. So let's suppose. Sorry for that. Let's suppose this is our optical fiber here. There is basically two parts. One is called core and one is called the cladding here. Draw a line properly. Let's suppose this inner part is called core and the outer part is called cladding here. Okay. So if this is of medium N1, this is of medium N2, what happens inside the optical fiber is basically called the total internal reflection. That we have to ensure that all the rays whichever are entering in the optical fiber should do total internal reflection and should not refract anywhere. Okay. So for which let's suppose there is a light which is incident at an angle of I here, will definitely get refracted here and will make some angle of theta here. Now this theta should be more than the critical angle. What is critical angle? Let's suppose this is a medium of N1 and N2. So we will write Snell's law, that is N1 times sine of I should be equal to N2 times sine of R here. Okay. So when basically total internal reflection happens, so the R becomes absolutely equal to 90 degree like this. See, this is normal here. It comes like this and goes like tangentially to the surface here. Sine 90. So sine I becomes here the critical angle, that is theta C. So theta C will be equal to, or sine theta C should be basically greater than N2 by N1 here. Okay. So this is the condition of the total internal reflection. Now moving on to our question 1, we will read that they're given two kind of structures with their N1 and N2, basically like core and cladding refractive indexes have been given here, N1 and 2, and given all the things here. Now they are asking for numerical aperture. That is basically like they have given the definition also. What is new? It is nothing but the sine of I here. Okay? So we have to equate them or whatever with the given conditions here, because they have given water, medium, and something like that. Okay. So what we will do here, we will derive a common equation and we will then put all the values to find which of the relations or which of the options are correct here. Okay. So you can see we can write something like this, and now uh, sine theta should be greater than N2 minus N1. Okay. Then we will be having uh, a condition here at this point. I'll show you at here. If you look at there, so what is we apply Snell's law here? So we have to write, let's suppose this indices as N3. Okay. So N3 times sine of I should be basically equal to our N2 times the if this is theta here, this should be 90. So this angle is nothing but 90 minus theta. So N2 times sine of 90 minus whatever is our theta C here. Okay. And what is 90 minus theta C? We can write it into the term of cos here. So N3 times N3 times sine of I, this should be equal to N2 times cos of theta C, which can be written as 1 minus sine square of theta C. I hope this is clear here. Now, since we do not want any kind of root terms and all, so we will do the square here. So if we square here, so we will get N3 square into sine square I, this should be basically equal to N2 square into 1 minus sine square theta C. Okay. And from here, if you know that, like, let's suppose if we say that 2 is greater than 1, but minus 1 is actually greater than minus 2. So basically, where I want to tell that whenever we put a negative sign, so the greater than or lesser than sign changes here. So with that, what I can write here is, we know that I think I should write on the different part here. It will be getting mixed then. We know that sine theta is greater than N2 by N1, but negatives of sine theta, or sorry, basically sine square theta will also be greater than n2 by n1 square. And if we put a negative, then sign will change basically. It will be like minus of sine square theta will be less than minus of n2 by n1 whole square. Okay. And if we can add both side 1, 1, so we have got that 1 minus sine square theta is less than minus of, sorry, not minus, 1 minus n2 by n1 whole square. I have this part is clear because now we have to use this relation only to put here. Okay. So, okay, now we can write here is, we can, I think, simplify this equation only. What I will do is, 1 minus sine square theta, this should be less than n1 square minus n2 square, and if you multiply n1 square here, okay. So see, we have basically got the same term here. I think there should be a like confusion or what. N1, N2, okay. So, oh, sorry, I have written, I think, wrong here. Because see, this surface we have called it as N1 and this one is N2. So N1 should be here. This should also be N1 and this should also be N1 square, okay. So see, we have now got the exact the same term here. And this part is also equal to, so we can compare directly them. So we will write it as N3 square sine square I. This should be less than n1 square minus n2 square, and from there we basically can find the relation of I that we have to find here, Im. Okay, so this should be Im is the just critical part, so less than equal, when we will equate them, then we will get the Im here. So Im is equal to nothing but root under, I think not over the whole, n1 square minus n2 square by n3 here. Okay, now what is n1? N1 is the core refractive index of core. This is of cladding, this is of the exterior here. Now basically we have to put option wise and get which of the options are correct here. Okay, now if you look at option A, so for S1 it is N1 is equal to root under 45 by 4. Okay, so our formula is N1 square minus N2 square by N3. Okay, so now we will be putting them one by one. So let's start. Okay, N1 square, that is 45 by 16 minus, like I will erase it one by one, and 2 square, that is 9 by 4. Okay, so basically it is equal to 36 by 16 only, and divided root under and divided by what is n3. N3 for S1 it is water, so it will be 4 by 3. Okay, so if we see 45 minus 36 is 9 by 16, that is 3 by 4 by 4 by 3. So it is coming equal to 9 by 16. Let's see whether S2 is giving the same thing or not. So for S2, let me erase all this here. For S2, N1 is equal to 8 by 5, that is square will be 64 by 25. Subtracting N2, that is for, I think, 49 by 25 by, it is in the 16 by, medium of 16 by 3 root 15. Okay, so this should be in the root. Yeah, so 64 minus 49, it will give us 15 only. So root 15 by 5 into 16 into 3 root 15. Okay, so 15 will give us 15, and 5 3 3, so it is also coming equal to 9 by 16. It means that they are giving the same value, so same as that. It means option A is completely correct here. Now we have to check for option B. See, it's getting too lengthy here, but I'll quickly solve here, don't worry. Now checking option 2 here. So Na of S1 immersed in liquid of this. Okay, so basically like we can have note down the upper values because it will be same only, N1 square minus N2 square. So what it was actually, 45 by 4, 36, 9 by 16. So this is 9 by 16. So it is basically it was 3 by 4 only, I think, and divided by the medium. Okay. So now it's medium of refractive of 6 by root 15. Okay. So root 15 will be there, and so ultimately it should be 3 root 15 by 24 or root 15 by 8. And checking for the S2, it should be like it is in water. So what was its numerator part? Let me write it again. I forgot that. So 8 by 5 minus 7 by 5. So 60. Okay, root 15 by I think 25. So root 15 by 5. And dividing it with what is its medium? It is in water. So 4. So basically 20. 3 root 15 by 20. So here you can see that it is not coming equal here, but like, so it means that they are not same. So option B is incorrect here. Now again 3 by 4 divided by, it placed in the air, so it is it will be same. And H2 is in the 4 by root 15. So what was its answer? So it was root 15 by 5 into 4 into root 15. Okay, so 15 by 20, which is 3 by 4. I think yes, option of C is also we are got correct. So 15 by 20 is nothing but 3 by 4. So we can mark our option C also correct. Now Na is in air and H2 is in water. So 3 by 4. I think it won't be correct. Absolutely. We know that like root 15 by 5 into 4 into 3. So 3 root 15 by 28 is never gonna match. So we can mark our option D as incorrect. Okay, so we have solved part 1 only up to here. So let's move on to our question number 20. So let's see. So they are given two structures of the same cross-sectional area, okay? But the numerical aperture N1 and are joined longitudinally. The numerical aperture of the combined structure. Okay, so they are asking for a relation here. So we can derive it through. This is actually quite simple here because you just have to assume two things. I'll show you how. Let's suppose this is our, sorry for that. Let's suppose this is our structure 1 and another structure will be, I think I have to make it of same area. So this is of same area, but they have different numerical aperture. For example, let's make a normal here. We know that in an optical fiber, it enters at an angle of I, then also releases, because it is very much symmetric. So it also releases at an angle of I only. Okay. I think I should zoom this out. So basically what will happen here, let's suppose this was earlier normal and it came at an angle of I only. So if we make another normal, I think I should shift it right like here. Okay. So here will another normal will lie here. So what it will do, it will make the same angle I1, like it was IM. So it will be also equal to IM. But since Na2 is less than Na1 given here, so it means technically what we should do is that like we want our ray to pass from both of the optic rays. So ultimately what we have to do that if it passes from a numerical aperture which is quite less than, so it will definitely pass from the numerical aperture which is more here. So what we have to do that we have to assume a common numerical aperture that will let them pass here. So finally the answer will be nothing but which one is the less. So lesser is the D here. So combined they have to like put any medium of numerical aperture Na2. Okay. So then only they will pass the both of the optic rays here. Thank you everyone.